All right, y'all, today we are going to continue talking about probability, but we're going to have some new vocabulary words for you as well. So in our past couple lessons, we've talked about probability as the likelihood of something to happen. So what are your chances of something happening? And we've been writing it as a fraction where the numerator represents the event we're looking for, and the denominator represents your total events. Okay? Well, now we have a new vocabulary word. And our new vocabulary word is theoretical. So what theoretical probability is it sounds like that word theory. And if something's a theory, it is a prediction. But it doesn't necessarily mean that it's going to happen for sure. So if we have theoretical probability, it is a fraction based on what should happen. So that's kind of what we've already been doing. So if you think about it, it's what should happen based on the numbers, but doesn't necessarily mean it's going to happen. So let's look at a couple of examples to help you out. So the reason why we have theoretical probability is to make future predictions. So you can actually use probability in real life in multiple different ways. So let's say that you have this spinner. And if you are spinning the spinner only one time, what is the probability of spinning a 2? So again, the numerator is how many 2s, sorry, I couldn't say that word for just a minute, how many 2s there are, and the denominator represents your total numbers. So the numerator is the events I'm looking for, so the probability of spinning a 2. So I look over here and I see 1, 2, 3 2s. So I'm going to put a 3 as my numerator. Then I count how many total numbers there are. So I'm just going to start where the arrow is to make sure I can count up all my numbers. 1, 2, 3, 4, 5, 6, 7, 8. So there's a 3 out of 8 chance that I'm going to spin and land on a 2. So that's saying if I were to spin a total of 8 times, there's a likelihood that I would land on that 2 3 times. Okay? Another important thing to note about probability, the pieces have to be equal size. For example, if this whole part was a number, one of the 2s, then it wouldn't be even as in, not even as even number, even as in fair, to land on that spot. So see how, notice how each of these pieces, they kind of look like pieces of pie on this circle. They're even pieces. So that's where something else we need to know about probability. Okay? It wouldn't be fair if maybe this whole half was one piece as the number 2, and then you had 4 over here. Okay? So that's something else we need to know about. Well, let's take it a step further if we're going to make these predictions. So it says, if you spun the spinner 40 times, how many times could you land on a 2? So we're going to think about what we already know. So we're talking about the probability of spinning a 2. This is what we just found out. So my numerator represents how many 2s, and the denominator is the total numbers, your total possible events. Okay? So in case you forgot about this one table, it's a proportion. So in words, what is being compared? The original ratio is the probability as a fraction. That's what we already figured out. So my original ratio is based on the picture, what I have seen. So what should happen is I should land on a 2, 3 out of 8 times. Okay? Well, now I'm going to use my blue right here for prediction, and I'm going to make a proportion. Remember, a proportion is 2 equivalent ratios. So we have the ratios being compared, a comparison between 2 numbers. So we're comparing how many 2s to how many total numbers there are in this situation. Okay? So my prediction, well, let's see what number we need. If we spun 40 times, so we have to think about where that number is going to go. Does it say how many total numbers were there if you spun 42s, or the total? So if we spun 40 times, we're going to put that 40 there. Then we put an X. Okay, so this is bringing it back to solving with proportions. So remember, with proportions, we can cross multiply and divide, or we can look for a scale factor or factor of change. So we can cross multiply like this and say 3 times 40 is equal to 8 times x and solve as an equation. So I'm going to remind you a couple ways because it's been a while since we might have talked about proportions. So 3 groups of 40, or 3 times 40, is 120, and that equals to 8x. A number in front of a letter means to multiply, so we're saying 8 times some number is 120. So in order to get x by itself, we do the inverse or opposite operation. So the opposite of multiply by 8 is divide by 8. I'm going to show you a separate way too, just in case you guys forgot. Okay, so 120 divided by 8. 8 can't go into 1. 8 goes into 12 one time. 1 times 8 is 8. 8, 9, 10, 11, 12. So 12 minus 8 is 4. Subtract and bring down. Then 8 goes into 40 5 times. So that is the consistent way that you can always solve. So x is equal to 15. But another way we could look at is you can see right here, from 8 to 40, we can say 8 times 5. So from left to right, that's called a between scale factor when we multiply. So if I do that left to right on the top, 3 times 5 also gets you to 15. Okay, so we can cross multiply 3 times 40 and divide by that other number. Or we can look for that scale factor where we multiply, or factor of change when we divide, either between left to right or within top to bottom or bottom to top. So that information is coming back. But what does this 15 represent? 15 twos. So how many times would you expect to land on a 2? So we'd say, I would expect to land on a 2 15 times if I spun 40 total times. Okay? So something to think about. Now again, this is just a prediction. This is a theoretical probability. In theory, if I know there's a 3 out of 8 chance of me landing on a 2, and I'm spinning 40 times, then I should do 15 out of those 40. But you could be exactly 15 that you land. You could spin the spinner and only land on it once out of 40. You could spin the spinner and land on a number 2 all 40 of the times. It could vary, but this is my prediction based on my theory of what I see with my proportion. Okay, let's keep going. Let's do 2 more examples, and then of course you can pause, rewind the video as needed, and reach out to your teachers as you need help. So we're going to use that proportion table that we practiced with a lot earlier this year to help you guys to solve this. So it says if SB rolls a number cube 20 times, so a cube is a 3-dimensional square, how many times can she expect to roll on an even number? So let's think about it. If it's a cube, a 3-dimensional square, your numbers are 1, 2, 3, 4, 5, 6. We want to know about an even number. So I'm going to say we're comparing the even numbers to the total numbers. So in words, what am I comparing? So my first fraction is going to be my probability. So in theory, I am looking for your even numbers. So we are looking for those even numbers. 2, 4, and 6 are my even numbers. So there's a 3 out of 1, 2, 3, 4, 5, 6. There's a 3 out of 6 chance of you landing on an even number. So that's what we've been practicing in our previous lessons. That's not new. But what's new now is looking at our new ratio. That's where we're making the prediction right here. So what are we looking for? If she rolls the number cube 20 times. So it doesn't say how many times if she rolls even. If they say 20 times, that means your total. Okay, so we can put an X here. So here again, we can say 3 times 20 and divide by 6. But there's actually another way. You see how you know the numbers on the left? We know both bottom numbers. Well, check this out. I can say 6 divided by 2 is 3. So that's called a within factor of change. So what I do to the left, I do to the right, from bottom to top. So 20 divided by 2, we are saying that x is equal to 10. Okay? So if you can see those scale factors or factors of change, it actually makes it a little bit easier. But if you don't see it that way, you can be consistent and say cross multiply. So 3 times 20 is 60, and then divide this other number. 60 divided by 6 would also give you 10. So this is why when I taught you guys proportions, I showed you multiple ways, because I want you to do what works best for you. Well, what's also nice about the labeling is, what does that 10 represent? 10 even numbers out of 20 times that you roll. So that would be my answer. We don't want to just write 10. We want to write what that represents. Okay, so we can say SB could expect to roll an even number 10 times out of 20 times. So what does that 10 represent? We don't want to just write 10, because sometimes if this was a test, they might have said 10 and a different label. So they could have said 10 5s or 10 3s or something like that, but it was 10 even numbers specifically. Okay? All right, let's do one more together, and then of course if you need help, let us know. It says, if Austin flips a coin 32 times, how many times can he expect it to land on tails? Well, first of all, if you have a coin, you either have heads or tails. So when we list these, this is called our sample space. What is our sample of what we could pick? So there's only heads or tails on this one. So we are looking specifically for tails. Okay, so tails out of total sides of the coin. Okay, this one was total numbers because we were listing those numbers. So my original ratio, well, think about it. If you flip that coin in the air, there's a 1 out of 2 chance, because here's heads, tails. There's one side is tails out of 2 total sides. Okay? And it says we're flipping the coin 32 times. So that 32 says total sides, well, because you're flipping it over and over, total events. So something to think about. So we'd have our theoretical probability like we've already been talking about, and this new ratio is going to be where our prediction is. That's why we have it labeled like this, and I'm using those colors to coordinate with it. Okay? So we can cross multiply and divide. 1 times 32 is 32, and then divide by 2. So 32 divided by 2, let me get a little bit more workspace. 2 goes into 3 once. 1 times 2 is 2. Subtract, bring down. And then 2 goes into 12 6 times. 6 times 2 is 12. Okay? That's supposed to be a 0. I just ran out of room. So x equals 16. But again, if you label this, this represents what you see. 16 time for tails out of 32 total sides, really meaning total flips in this one. So we can say Austin, because again, expect. Austin can expect, so this is just in theory, he could flip the coin 32 times and land on tails 30 of those 32 times, but this is just based on prediction of a 1 out of 2 chance. So Austin can expect to land on tails 16 times when he flips a coin 32 times. Okay? So again, theoretical probability just is in theory what should happen. Doesn't necessarily mean it's going to. We'll talk about more of that in the next coming up lessons. All right, well, thank you guys for paying attention to this. I hope it was helpful, and of course, please reach out to your teachers as you need more help.